Welcome back to VTU e-Shikshana program on engineering drawing, that is computer aided engineering drawing. We are in module 1. So far we have covered projection of points, lines and planes in module 1. Now we are going to revise and work out the very basic fundamental concepts which are very helpful in completing the typical problems on straight lines first, and then I will take up on planes. Now let me discuss the two figures which I have worked out here, identified here. One is the line is inclined to HP by theta, and the corresponding apparent length is this. Here there are three parameters. One is true length of the line and inclination of the line with HP, and the top view length, that is apparent length, number 1. Number 2, here is the inclination of the line with VP, phi. Angle of inclination with VP is phi, and corresponding front view is apparent length. And then the angle, true length and apparent length, three parameters are there. Here also 3 parameters. So far we have worked in the basic problems which are having true length and theta and true length and phi. And whenever we used to get these two, draw these two according to the first the fixed end location, and then get the corresponding top view. Similarly, give inclination to the VP according to the true length given, and then get projected onto the front view and get the front view. Whenever line is parallel, that is projection line is parallel, and opposite view is always true length. Here also same, the line is, projection line is parallel to XY line, definitely the true length is A dash B dash. Now we have two typical problems we will take up and then discuss how exactly we can work out this. It's very simple again. Here what are given we will take up. The line AB 80 mm long has its end A, line AB 80 mm long has its end A 20 mm above HP, and the line is 30 mm in front of VP. Draw the projections when its top view measures 60 mm. Find the inclination of the line with HP. So what all given here? True length is given 80 mm and top view length is given, that is 60 mm. So we have to find out theta, how much, that is the inclination of the line with HP. So normally these two will be given, we are going to identify this and then proceed. Now let me take up this. Draw vertical line to fix one end of the line, that is fixed end, that is A dash 20 mm above HP, and then the line itself is 30 mm in front of VP. Let me take a simple model and explain to you. This is the line, it is inclined only to HP by theta. We don't know the value of theta. We know the true length and the apparent length, top view length. 30 mm in front of VP. The entire line, length of the line is 30 mm in front of VP. The one end of the line is 20 mm in front of VP, above HP. So this is the situation. Okay. So front view is true length, top view is apparent length, we know. So apparent length is given and then true length is given. So we have to find out theta, that's all. So we have worked out basic problems of this type. Now let me take up this here. We don't know the inclination, so we cannot fix the true length in front view. So I can fix the top view. Since I know the line is inclined only to HP, the line is 30 mm in front of, that is parallel to VP, you can draw a line 60 mm. So this length is 60 mm. This is A, this is A dash, this distance is 30. Total length, entire length of the line is 30 mm in front of VP. Now, see, just observe here, I have AB fixed, top view. Then I have to fix this. Draw the locus, vertical projector of B. So A dash is on a vertical projector. Similarly, B dash must be a single vertical projector. So what I do is I draw vertical projector of B having the length fixed here. Then how to locate this B dash? I know true length value 80 mm fixed. This one is utilized. Now I have to find out this. What I do is I keep A dash as center, draw an arc with 80 mm equal to radius. This particular point is B dash. So this is how you get the front view. Join this. Then the associated angle with respect to XY line is theta. So you have to measure this. That's all. So first fix the one end of the line A dash A, 20 mm above HP and 30 mm in front of VP, because line itself is 30 mm in front of. Fix 60 mm parallel to XY. Project B and get the vertical projector. Draw an arc which strikes this vertical projector at B dash. This is, now you can find out the angle. So now answer is angle theta. How much? Let me take up second problem. A line AB inclined at 45 degree to HP has its end A 20 mm above HP and line is 30 mm in front of VP. Draw the projections when its top view measures 60 mm. Find the true length of the line. It is very similar to this, except that the true length is not given here. True length is missing here. Angle is given, theta is given, top view length is given, and we have to find out the true length. Okay, so now I will show you the situation, how exactly this line see, this is the situation. Again, same situation. The true length is here and top view length is given. We have given this 45 degree inclination with respect to HP. Then we have to get the true length. That's all. Same situation. Now let me solve this. XY line. Then fix one end of the line, A dash, then A. This is 20 mm above HP, similar to the previous problem. Then this is 30 mm in front of VP, because the entire length of the line is 30 mm in front of VP. Definitely this. Now here also we have the true length, that is the line is inclined only to HP. So definitely the top view will be straight line, that is given 60 mm. So let me dimension that 60 mm and dark this, because this is required. This is the final top view for us. This point is B. Now to get B dash, front view. So similar to the previous problem, draw the vertical projector. This is very fundamental thing. Instead of true length, he has given angle. Now here theta is, we are going to find out. Here theta is given, we don't know the true length, but that angle you mark, draw a line with a inclination of 45 degree. Definitely it strikes this or intersect the vertical projector of B at B dash. Now the front is this. So this is how you find out the true length. You measure true length, how much it is. So this is the true length value. So here also you have to dimension this. If this is an individual problem, so you have to keep this. This is the true length. Given here, true length is given. Then here you have to find out. So finally you say true length is how much. So similarly, you will get for this problem, this type of problem also. You will be given front view and true length. First what you do is fix this one end and then keep the front view value, then project and get this. I will show it to you on the computer. Okay, this is about the problems on straight lines, very fundamental problems on straight lines. And also I repeat, I will use these two figures. Whenever the line is parallel, that is projection line is parallel, always opposite to is true length. Here also same, always the parallel line and the opposite projection, always this is true length. So we will work out the same in the computer. Let me take a simple problem on straight line with a true length given and one end of the line is fixed, like a line 80 mm long is 20 mm in front of VP and inclined at 40 degree to HP. One end of the line is 15 mm above HP. So here 20 mm in front of VP, the line is 20 mm in front of VP and one end of the line is 15 mm above HP. So this is the 3D view of the line. This is Z1 is actual line, say in space, kept in space, and A dash B dash is front view, it is on VP, and top view is AB. Here is the projection XY line is the standard pattern VP HP, and we have to draw first the front view, since we know the true length and true inclination. Whenever a line is parallel to a plane, on that plane you get true length. So definitely A dash B dash is 80 mm and the one which is projected 20, since the line is 20 mm in front of the entire length is 20 mm in front of VP, that is XY line AB. AB is parallel to XY. Whenever a line is parallel, opposite view is always true length. That's what we used to discuss. Now the corresponding final view is this. Okay, XY line and front view, top view. Next comes inclination to VP. The line is 20 mm above HP and one end of the line is 15 mm in front of VP. The line is inclined 40 degree to VP. That means the line is parallel to HP. That's why the line is true length here. That is AB is true length. Since it is parallel to HP, you will get true length, and corresponding front view is apparent length. It is A dash B dash is apparent length and AB is true length. The original line is AB in space. Okay. Next comes the problem. This is the solution for the same, and here is the general information. Whenever a line is perpendicular to XY line, parallel to XY line, inclined to XY line, we always interpret the line is perpendicular to HP, parallel to HP and inclined to HP. Similarly, we have XY line with the line perpendicular, parallel and inclined. Here is the line is perpendicular to VP and parallel to VP and inclined to VP. Whenever you get a problem, you have to get the information that whether it is inclined to HP or inclined to VP. Then you start working. Next comes the line is inclined to HP and parallel to VP and inclined at some degree to HP. The corresponding side view is this. This is the way you draw the side view. So this is 3D view of the arrangement. Same arrangement I have, but included the RPP here, and then corresponding solution is this. The line is inclined to HP, parallel to VP. And how to get the side view? So you draw 45 degree line with X1, Y1 intersection with XY line, and then project through 45 degree line and get the side view. So next comes the inclination to VP. So again corresponding side view. So A double dash B double dash is side view on RPP. Okay, this is front view, this is top view, this is the actual line. The line is inclined at 40 degree to VP and parallel to HP. So the corresponding projection is this. So the line is inclined to VP by 40 degree and it is 20 mm above HP, entire length is 20 mm above HP, and the corresponding side view is this. The one end of the line is 30 mm from RPP. Yes, it is fixed here. And how to get the side view? Draw 45 degree line, then project A, B, that is top view through 45 degree line. You will get a single projector, you get A double dash, B double dash. So this is side view, front view, top view. Next comes the problems which you worked earlier. A line AB 80 mm long has its end A 20 mm above HP and the line is 30 mm in front of VP. Draw the projections when its top view measures 60 mm and find the true inclinations of the line. So whenever a line is parallel to a particular plane and that plane you get the true length. Here is the standard problem we have worked out already. The line is inclined to HP and parallel to VP. Here the three parameters are there. One is true length, and then top view length, and then inclination. Here inclination is not given. You have to find out inclination, but true length is given and top view length is also given. So whenever the line is inclined only to HP, the corresponding top view is apparent length. So apparent length is given, make it parallel and fix 60 mm as per the given reference. Then project from this B towards the front view. Then A dash as center, draw an arc. So here is the procedure: project the point B, that is top view of one end B. Then A dash as center, draw an arc. You get the true length and corresponding inclination with 8 mm equal to radius. Next comes the final view, final projection. A dash B dash is front view, AB is top view, given 60 mm and 80 mm. This one you have to find out. So that is what the inclination of the line with HP is 41. You measure and say how much it is. So this is how you find the inclination of the line with HP when true length and apparent lengths are given. Similarly, we have the inclination is given, true length is not given. So out of these three, two will be given and one more will be we have to expect, we are supposed to find out. So then same procedure, instead of projecting and then draw an arc, you project it and then draw an inclination, that is true inclination with HP, that is 45 degree. So what you do is keep this projection of B, then if you know true length, you draw an arc. No, we don't know true length, but we know true inclination. Draw an angle, line with 45 degree, that is what true line inclination is given. So theta is given 45 degree. Intersection gets you the point B dash. So the A dash B dash you dark, that becomes your front view. Okay. So this is the front view. So this is how you get the information regarding whether the angle is not given or true length you have to find out, or the top view length is given. If these two are given, definitely you can find out this. Otherwise, true length is and the top view length is given, you can find out. So some more further, we have the reverse problems of the same type. 8 mm long has its end A 20 mm in front of PP, and the line is 30 mm above HP. Draw the projections when the front view measures 60 mm. Earlier we had the top view, now it is front view. Same type, draw the projection and A center, draw an arc with 8 mm. Then you get the final view. Okay, see, project it, A center, draw an arc. So that is how you get the true length. Okay, AB is true length, you dark it and get the true length. So similarly, you can think of angle is given 45 degree to VP. So earlier we had 45 degree to HP and top view is given. Here front view is given and top 45 degree is given. Draw 45 degree line and project it. Intersection gets you the point B. So AB is top view. See, this is how you get the things. We will work out some more problems on planes which are very typical in nature. Now I will take up the problem number 1. Rectangular lamina of 60 mm by 40 mm size has a smaller side on HP such that the lamina is inclined at 45 degree to HP. Draw the projections when the side on HP is inclined at 30 degree to VP. I will take up the same. Already we have worked out this problem, but just for a particular purpose I am working again. See, this is the model A, B, C, D. I have 4 corners and he says smaller side on HP or smaller edge on HP, shorter edge, all are same. I have to keep this particular edge perpendicular to VP. First position, second position. So in second position we have the lamina inclined at some degree to HP. So here we have first figure, top view, front view, and this is the first figure, and second figure, front view is line and top view is apparent shape. Sometimes it may be square, that depends on the situation. Now the edge on HP is inclined at 30 degree to VP, like this or like this. So that's all. So the corresponding solution is here. The lamina is on HP, the shorter edge is perpendicular to VP, so that we can rotate about the shorter edge. The lamina is inclined at 45 degree to HP, the corresponding top view. Now, the edge which is on HP is inclined at 30 degree to VP. So, correspondingly we got the front view. This is one set of problem. The similar problem I have, let me show you here. A rectangular lamina for 60 mm by 40 mm, same size I have taken, has its smaller side on VP. Instead of HP, I have given it on VP, such that the lamina is inclined at 40 degree to 45 degree to VP. So, here is the second problem and corresponding explanation. Here is the front view. Initial position. The smaller side on VP, that's why I have taken perpendicular to HP, that you know. Now, whenever the lamina is parallel to a plane or on that plane, I will get true shape. True shape is the front view, and corresponding top view is line on XY line only. Okay. Next, I give inclination to VP such that the smaller side on VP. So, I have given inclination to VP. So, front view will be the apparent shape. First position, second position. Next, what I do is I will keep the smaller side on VP inclined at 30 degree to HP. Right now, first position and second position I have maintained perpendicular to HP, so that I can give inclination only to VP. Now, I give inclination to HP for the edge on VP. So, first position, second position, third position. We can see the similarities here. The HP and VP. See, here 45 degree to HP, in this case it is 45 degree to VP, lamina inclination, and the edge on HP is inclined 30 degree to VP, here 30 degree to HP. So, I refer this particular set of problems as regular problem. This is reverse of this, or this is regular problem and this is reverse of this. I will show you with a simple model. Here is the solution for this problem. So, first position, here, this is the second position, this is third position. I have named it also, you cannot see clearly. See, this is the situation. Now, if you want to get that particular solution, so you can work and realize one or two problems, and then just you do this, just reverse the page, reverse the direction without naming, so that you will get reverse naming type. So, here same sheet I am taking, see this is green color, I am showing the solution for this. See here, first position, second position and third position. The only thing is you have to rename it. You remove the name, reverse the sheet, reverse the direction and do it. In computer, what best you can do is solve a problem, solve this problem and then remove all naming. You mirror it, definitely you get. I will show you it on the computer. You mirror it, you will get the solution for the reverse problem. So, when you call a reverse problem, this is regular problem. You see rectangular lamina, this is smaller side on HP. Here I have given smaller side on VP. That's all. HP becomes VP. The lamina is inclined at 45 degree to VP. Here this becomes HP. And also the edge on HP is inclined some degree to VP. HP. Here VP. This is HP. So, must carefully do it. If you can able to do this, if you draw a reverse problem, you learn more. You can do wonders in the lamina topic. Now, what I do is, in computer, I will work out this and also I will work this. I remove the naming of all this. I mirror it and show it on the computer how exactly you get the solution. Or you can take this as the base, first problem, and you mirror it or reverse the sheet, reverse the direction, you get the solution of this. This type of problems, you can do it for any shape. I have a number of problems solved in the computer, so that I will show you. This is very interesting problems you can solve. Okay, any number of problems. Only thing is, you should not have side view. If you have side view, that cannot be done. Okay, so if you have simple problems with one position, two position, three position, only top and front views, you can reverse the sheet, reverse the direction manually, or in computer, just mirror it, you get the solution. So that will work out in the computer. Let me discuss reverse problems, particularly laminae, you really enjoy the number of problems which are reverse problems for a given problem. Now, here for example, take rectangle as the reference. A rectangle or lamina of 60 mm 40 mm size is a smaller edge on HP such that the lamina is inclined at 45 degree to HP. Draw the projections when the edge on HP is inclined at 30 degree to VP. Here we have the lamina a smaller edge on HP such that the lamina inclined 45 degree to each HP. That means the lamina inclined to HP means you have to make it parallel so that you get the true shape on HP. Yes. Then the smaller edge on HP means you must make it perpendicular. That is what I have done. The initial position is this, the lamina perpendicular to the one of the edge, the smaller edge perpendicular to HP and top is true shape, get the projection. Then give inclination to the HP with reference to the first figure front view. Okay. Next get this, that you know. Next comes the edge on HP, that is AD, only AD, not any other line, is inclined at 30 degree. No doubt BC is also parallel to AB, AD, but you must dimension this. Even if you take to this, you must dimension this and preferably you keep it towards XY line. Then project it, get the things. So, this is a particular problem on rectangular lamina. Now, I will give a specific problem which is actually referred to as reverse problem. What is reverse problem? As a smaller edge on VP I will take, instead of HP I will take VP, I have discussed already. Such that the lamina inclined at 45 degree to VP. Draw the projections when the edge on VP is inclined at 30 degree to HP. So, that is what I explained here, you see. A smaller edge on VP says that completely reverse problem. Okay. 45 degree to VP, draw the projections when the edge on VP is 30 degree. See, the lamina is placed on VP such that one of the smaller edge is perpendicular to HP. So, that about that you rotate by 45 degree, then you get the apparent shape. Then the smaller edge on VP is A dash D dash here. Actually AD, in front of it is A dash D dash. A dash D dash I have taken 30 degree to HP. So, whatever you do here, that is for HP. Now, this is the final solution. Now, you just observe, compare between these two, and let me take the first one and second one and show one below the other. See, this is problem number 1, problem number 2. This is regular problem, this is reverse of this. So, you can have the information that whatever is there, it is just reverse of this. So, otherwise also you can have, you will take the second problem as the first problem, okay, and then do reverse, they compare it. Okay. Now, how to get this answer very easily? If you know one answer for one problem, definitely you can easily find out other problem. Let me take a simple thing. So, this is answer for first problem without naming, I have not named, because if you do reverse, that name also becomes ulta. So, how to do it? You just mirror it. If you take a sheet of paper and just reverse the direction, reverse the sheet, you will get the solution if the sheet is very transparent. And okay, then here in computer what you do is you remove all the naming and then keep it like this and then mirror this figure, you will get the solution for the reverse problem. So, I will show you how to do it. It is very easy job. Take this mirror, select this and then mirror about this line. Yes, that is all. See, this is what you get. Now, I will show you the same comparison, same pattern you get here. See, regular problem, no naming, that is all. You cannot keep naming and do it. So, similarly, you can take the inclination to VP first and then get the corresponding inclination to HP reverse problem. So, problem 1 is reverse of problem 2, problem 2 is reverse of problem 1, that is what. Now, without naming, whatever I have done I am showing you here. Again, if you take regular problem, that is inclination to HP, the regular problem inclination to VP is the second, that is reverse problem. Here I have done ulta. For problem number 2 I have taken and then I have made the reverse problem, this becomes solution for problem number 1. So, the same way now I will repeat what I have done there. one by one for all problems I am doing it. Now take this, how to do it, mirror, okay, then about this line, I have drawn a line. Now problem number 1, that is, this is problem number 2, reverse of problem number 1. Similarly, if you take problem number 2, now let us find the reverse of problem number 2, that becomes answer for problem number 1. Okay, see. Yes, like this we can go for number of problems. Okay, any problem you take, if you work out 10 problems, you get 10 more problems as reverse problems, but without labeling, only reference you get, you can understand easily. Now you take a typical solution. A circular lamina has its Riemann HP, such that the lamina, surface of the lamina is inclined 45 degree to HP, and the diameter passing through the point on HP is inclined at appears to be inclined at 45 degree to HP, or inclined at 30 degree to EP, that becomes beta becomes 45 degree. Now what about the reverse of this problem? See, here only I will read, as its Riemann VP, such that the surface of the lamina is inclined at 45 degree to VP. Here HP replaced by VP. Draw the projections when the diameter passing through the point on VP is inclined at 30 degree to HP. See, this is the solution. This is the reverse problem. Okay. Now I will compare. I will keep one below the other. So this is regular problem and this is reverse problem. Inclination to HP is reverse regular problem. Inclination to VP will be reverse problem. Now I will do ulta. Inclination to VP becomes inclination to VP becomes a regular problem and this becomes a reverse problem. So without naming I am doing it. See, here this is when you take the whatever the information is available, same complete solution you can do ulta, and then that means mirror, you will get the reverse problem. So here I will do for the sake of working. Now I will take this and then go to mirror and do it. That is what. Yeah. Same way we can have a number of problems. This also you can do, mirror it and then do it. Now let me take a 30 degree 60 degree set square of longer side 65 mm as its longer edge HP on HP inclined at 30 degree to VP. Draw the projections when the surface of the lamina is inclined 45 degree to HP. See, surface of the lamina is inclined 45 degree to HP. The longer edge, that means 65 mm, is the edge is on HP here CA. Again the same edge is inclined at 30 degree to VP. So what will be the reverse problem? A 30 degree set square of longer side, longer edge 65 mm, as its longer edge on VP inclined at 30 degree to HP. Draw the projections when the surface inclined at 45 degree to VP. So say same thing I will show you here, same thing, this becomes reverse problem. How to get this without working? Just for reference only, you have to work and label properly, but get the reference just by mirroring it. See, you have a regular problem, try to reverse this, you get it. Okay, here it is labeling, whatever you have done I have copied here, but when it is worked out, see, this is regular problem and this becomes reverse. Then you treat this as inclination to VP reverse regular problem, this becomes reverse. So now see, this is what you get. Now I will work out for your this one reference, same procedure, mirror about this, yes. Otherwise if you take the reverse one, you can do reverse and get the answer. This is very interesting, just mirror it, you get the solution for the reverse problem. So, you can take any problem and then work out this reverse problem, you get better knowledge about the lamina, getting better understanding.